Hey everyone, it's Mrs. Dugan, and today we are going to be focusing on the next 3 steps of the scientific method. So remember, our first 4 steps are P for problem, O for observations, R for research, and H for hypothesis. If you need to review those, you can always go back to yesterday's video and look at the PowerPoint that is on today's slide. All right, so we're going to skip on through this. And today we are going to start with E. So E is our 5th step of the scientific method, and that stands for experiment. So your experiment is where you're actually going to test your hypothesis. Now, this test is designed to either support or disprove our hypothesis. It's not to prove it right or wrong, but it's either to support it or refute it or say, that's not really working. That's not what's going on. So when we have an experiment, it provides insight into our cause and effect relationship. So remember, we are using a if-then format for our hypothesis. When we have an if-then format, it's a cause and effect. We're changing something to see what happens in the end. Within your experiment, you have a couple different things called variables. Now we have 4 different types of variables that we're going to talk about. But a variable in general is just a notable factor in the experiment. A notable factor means that it is important. It's something that we should really take care to notice. And those 4 types are independent variables, dependent variables, control variables, and extraneous variables. And we'll get into a little bit more detail on those. So the first type that we're going to talk about is the independent variable. This variable is what you change. This is what you have control over. You're changing it, you're comparing it, you see what you're using that to see what happens in that cause and effect relationship. That abbreviation is IV. So if you ever see that and it's talking about variables, it means independent variable. Now, the way that I think about independent, when we think of something that is independent, that means that it can do whatever it wants. So when you go to college, right, you have the freedom to choose what you want to do. When you turn 18 and you're an adult, you get to make choices. So that's the independent variable is that college student, that 18-year-old who gets to do what they want. It's things that change, all right? And when we look at the experiment in itself, and we try to identify that independent variable, we know that it's the first in the question or the problem. So for example, I may have a question that is, does the amount of water impact plant growth? What can change in there? What makes its own decisions? It would be the water amount, the amount of water. So again, it's the first part of the problem. It's also the if of the hypothesis. For example, using that plant again, that plant example. If I water my plant 3 times a week, then what will happen? So again, that independent variable is what changes, what is being changed or compared. It's also going to be in the first column of your data table. I want you to think of it as X. If we were in Mr. Schubert's class or your math class, X always changes. So your the first column in the data table is going to be X, or our independent variable, because it's making decisions and it's changing, just like you do in college. And again, it's graphed on the X axis because it serves as that X, or that thing that changes. The next one, just kidding. So this is showing you where your independent variable is going to be. In a data table, right at the top, you can see that it is in that first column. It is the one that changes. And then it's going to be located on the X-axis because it changes. It's that college student, it's that adult that gets to make the decisions. The next one is our dependent variable. This is what we are observing. This is what's being measured. This dependent variable depends on the independent variable. So I want you to think of yourself. Do you have a bedtime? Okay, my daughter has a bedtime that I have decided. She goes to bed at 7:30 every day. Okay. She is dependent, her bedtime is dependent on my choice. I am the independent variable. She is the dependent variable because she relies on me to tell her what to do. So when you're looking for your dependent variable, it's going to be abbreviated as DV. So if I talk about DV, that means dependent variable. It's going to be the second part of the question. So again, going back to that plant example, if the amount of water, our independent variable, does the amount of water being our independent variable, affect plant growth? So plant growth is our dependent variable because it depends on what the independent variable is. Okay, so think of it. You right now are a dependent variable because you have to have your parent. Okay, they keep you safe. They tell you what to do. They tell you to go to school. They tell you what what you're having for dinner. Okay, that you are the dependent variable because you do what the independent variable says. Now, in our data table, it has your first one is your independent variable, and all of the rest of the data is going to be your dependent variable. This is also graphed on the y-axis. On this screen, it's showing you that your independent variable is always the first column of the table. And that second, third, fourth, fifth, infinity and beyond, like Buzz Lightyear says, is going to be your dependent variable. Think of it as y. Y, like in math, Mr. Schubert says, x is that independent variable, y always depends on x, okay? Again, it's on that y-axis when it's graphed, okay? Because it's the thing that depends on the independent variable. Then we have control variables or constant variables. These are important things that need to be kept the same. So remember in our airplane lab, we talked about there were things that we needed to keep the same. We needed to throw the airplane at the same place. We needed to have the same person throw it. We needed to throw it the same way. We need to have the same airplane being thrown. Okay, so those are things that stay the same. And the reason why they have to stay the same is because they need to be consistent. If we change one of those, our data may be off. Okay, so for our coin experiment, if we are dropping it from a height, what are some things that need to stay the same? Some of those could be the height of which that it's thrown or dropped. Maybe what needs to stay the same? The height of where it's dropped, who is dropping it, because we're all different heights. Maybe the coins that we're using, because there may be an imperfection in a coin. I'm sorry. Let's see, the place where you're doing, the environment. So if you drop it in a classroom, you should probably keep dropping it in a classroom and you shouldn't go outside because there's different factors that could affect it. So remember, control are things that stay the same every single time. Our last one that we're going to talk about today are extraneous variables. So these are things that we have to anticipate because they're things that could go wrong. For example, with our extraneous variables for a coin experiment, what happens if you lose your coins? How are we going to anticipate that? What do we need to do? Another thing could be that you fall off the chair. What happens when you fall off the chair? What happens if you're not releasing them at the same time? What happens if the person isn't there that usually drops the coins? What are you going to do? So the things to remember is that the independent variable is the things that you change. It's the thing that's going to change, and it does it all by itself. The dependent variable are the things that we are observing. It's the outcome. It is the effect. So the dependent variable is something that you're not changing, but will change with the independent variable. Okay, think about what you go through as a kid, and your parents decide things for you. Okay, dependent depends on the independent variable. The control variable are things that have to stay the same every single time within the experiment. And finally, your extraneous variables are things that could go wrong. And these are the things that you need to anticipate. All right. You have to think of all the extraneous variables so that you can make sure that you are the most prepared for your experiment. Okay. Tomorrow we will talk about the next two. We didn't have enough time today in class, so there will be another video tomorrow that you'll watch. All right. If you have any questions, please feel free to message me on Schoology or keep watching this video. Have a good day, guys.